This podcast, we're going to talk about DNS and some DNS related things we need to know as network administrators. DNS is defined in RFC 1034 and 1035. It was probably updated in some later RFCs. I didn't bother looking for those numbers. It defines the structure of domain names. There's a lot of information in those RFCs about domain names and how they can be structured and all that kind of stuff. We're not really going to talk much about that because we're more interested in knowing how the mechanics of domain name lookups work and some tools we can use to find out domain name information. Because as network administrators, we're going to be the ones that are trying to figure out why things aren't working. And DNS is a big part of what applications use to communicate. So knowing how it works and what we should see and how to ask some questions is important to us. DNS is used to map names to IP addresses. So we type www.richisthebest.com. We need the IP address to go with that. Our computer doesn't actually operate on the name. It needs to get the IP address to do anything. DNS provides that mapping for us. It also can map IP addresses to names. If we have an IP address and we want to know what name that belongs to, we may be able to get that information from DNS if the administrator that owns that IP address has configured it, but that's not always the case. And then we can get other related domain information, other domain related information that we need. Like, for example, in order to send the email, we need to know who the mail servers are for a particular domain, and we can get that information from DNS as well. So we'll go over some of those things a little later on. DNS can use TCP or UDP. The port for DNS is 53. UDP is used for general queries. Basically, most of the time you ask a question, you get an answer. It takes 2 queries for that to happen. The responses and requests are fairly small, so there's no need to worry about needing to segment the data because the request is normally not going to be large enough to require two datagrams. TCP is used for zone transfers. A zone transfer is when you download all the information about a given domain from the DNS server, and usually that's only allowed to secondary name servers. So normally it's a security issue to let somebody download all your DNS information because then they can identify all the hosts on your network. So normally that doesn't happen unless you're a secondary name server. It's a query response protocol. I mentioned it uses UDP for most of the operations. You ask a question, hey, what's the IP address for www.hack.edu, and you get a single UDP packet reply that has the information you asked for. There's 2 different types of queries you might see. One type's recursive. With a recursive query, you ask the server the question, and then the server goes and finds the answer for you and then gives you that answer back. So the recursive query, you will see your query go out and then you will see a response come back in. An iterative query is a query where you ask the server and the server doesn't go find it for you. The server tells you who else you can ask next. So for example, we have this idea of root name servers that are kind of in charge of everything. They know where all the other name servers are. So if you ask your name server a question, say you want to know where hack.edu is, then your name server might tell you, I don't know, you should go ask the root name server. And you'll ask the root name server, and the root name server will say, I don't know, you should go ask the .edu name server. And so then you ask the .edu name server, and the .edu name server says, I don't know, you should go ask the hack.edu name server. And then you go ask the hack.edu name server, and then it finally tells you, oh yes, here's the answer you're looking for. So if you're looking at an iterative query, then you are going to ask your server and then some other number of servers before you see the actual response. So yeah. There are certain types of DNS records that you probably should be familiar with. You'll need to know these when you're creating records. You might need to know this when you're querying for records if you're trying to figure out why something's not working and you're asking the name server. You'll need to know how to tell it you want to see the mail server record. That'd be an MX record. So we have A records, IPv4 address, quad A records, the 4 A's, they normally call it a quad A record, IPv6 address. CNAME stands for canonical name, that's an alias, so that's when you point a name to another name. So for example, if I had, www.rich.com with an IP address, that'd be an A record. And then if I had another name I wanted to call that by. Say I wanted to call that web.rich.com. I can make web.rich.com a CNAME that points to www.rich.com. MX for mail servers, NS for name server. Start of authority has some information about the zone itself. Pointer, those are the records that map an IP address to a name. And then you can also have text records that contain text strings are used by different process, such as SPF uses those, I believe. So how do you get your own domain? Say you wanted to set up your own domain name, or you go to work for a company and they're still using some free or lame domain name, or they rename the company and they want to change their name, get a new domain name. Well, first you need to go to some registrar. There are any number of registrars. I actually Googled some registrars a second ago by my browser. Basically, you can go to any of these registrars and look for a domain name. GoDaddy's a pretty popular one. Once you identify a registrar, once you go out there, then you want to search for your domain name. The one I keep thinking about buying is richisthebest.com, because I use that as an example all the time. I was going to buy that and just put a picture of me that says, hey, this is Rich, he's the best. But it seems foolish to spend money on that. But anyway, I could buy that if I wanted. It only cost me $2.99 if I want to register it for 2 years or more. So you would go out here, you'd buy this. It's going to make you log in and stuff, probably. Does that say Rich is great? richisthegreat.com. That's a good one. So you'd buy this, you'd go on, they'd make you log in and pay for it. I'm not actually going to buy it and pay for it at this point. Yeah, no thanks. Good news. Oh, great. All right, so here it wants me to get 2 years. I would check out. And then once I checked out, after I checked out, what it would want me to do next is it would want me to provide the name servers for my domain. So that's this next step. Let me start this back up. Tell the registrar where to find your name server. So that'd be the next step. I'd tell GoDaddy, hey, my name servers live at these 2 places. I'd put 2 DNS names or IP addresses for where I could find my name servers. And then you would need to configure the DNS servers for your domain. Some useful tools. I spelled interrogate wrong. It's kind of embarrassing. Some useful tools you might use. You might need to ask a DNS server some questions, and a couple different commands you can use for that. NSLOOKUP and dig. Let's go do a few sample commands for that. I'm much more familiar with NSLOOKUP because it's the one that's been around forever. But sometimes you run it and it says NSLOOKUP, this command is deprecated. So the easiest thing to do with NSLOOKUP is to provide whatever you're looking for. So if I want to find out about www.hack.edu, I hit enter and it tells me some stuff about that. I have lb.hack.commonspotcloud.com, but that's telling me is this is a load balancer probably that our website actually points to. That actually points to it's a CNAME. This load balancer is a CNAME that points to this name, which is a Elastic load balancer at Amazon. So it looks like our website's actually run at Amazon, and there's 2 different IP addresses that we could get for that from DNS. So that was that. Another thing you want to do, as I mentioned earlier, we might want to know about the mail server for Hack. So you can also say -q equals mx. That says the q is the query type. What do you want to know? I want to know who the mail records are. And there are no mail records for www.hack.edu. They're just for hack.edu. So I press that, and that says, oh, hey, your mail exchanger is spamfilter.hack.edu. Lots of times it'll go ahead and get the A record, but I don't see that. So now I'm going to look up the A record for spamfilter.hack.edu. And there we go. That's the spam filter for Hack. So that's one way. That's running NSLOOKUP non-interactively. You can also run NSLOOKUP interactively, which means you just type NSLOOKUP, and then it gives you this prompt, and then you can ask your question. So I can say hack.edu, and it tells me the A record for hack.edu. The default is an A record. If I want to know the MX records, you do set type equals mx, and then do the query. That tells me the thing. Another thing you might want to do is you might want to change your server. If you look at this, I'm asking the server at 208.67.222.222 my questions. Say I want to ask a different name server. I'm type server 8.8.8.8. You will probably want to do this in the lab because your machine will be pointing to a different name server. But if you want to ask your own name server questions, then you need to tell it to ask it. So you'll do server space 127.0.0.1 is one way you could do that. So now I'm asking this other name server. This just happens to be Google's name server I use for testing a lot. Now I'm going to do the same thing, hack.edu. It still had the MX record, so I could do NS, look up the NS record. And this will show me the name server record. So there's my two name servers for hack. So that's NS lookup. Another tool you can use to look up names is dig. I'm not that familiar with dig because I use NS lookup all the time. So dig will tell you similar information. I just did dig hack.edu. It gave me an A record. If I want to do a MX record, I think I can do dash QMX, not equals QMX, dash QMX. Yeah, so it shows me. Show me the MX record. That didn't show me the right thing. So now I'm going to look at my man page because I just looked at this a minute ago and I can't remember. Dash T, not dash Q. Mixing up my syntax. It's dash Q for NS lookup. Dash T. There we go. So dash T MX gives me the MX record. Dash T NS will give me the name server record. So that's how to look up that information using dig and NS lookup. Another tool my slides talk about is we can find out information about domains. Another thing you might want to have to do someday is if say you're working for some company and you're getting spam from some domain, or you're getting attacked. I put that in air quotes. So you see, say you have some traffic hitting your firewall and you trace it back where it's coming from, and you think it's coming from hack.edu. So you can go out to the Whois sites. This is the ICANN Whois, and find out information about the domain name. If you look it up in the Whois, it tells you some stuff about the domain name. Oh, hey, this is Harrisburg Area Community College, 1 Hack Drive, Harrisburg, PA. Administrative contact, Teresa Richwine. Technical contact, Dave Schaefer. So if you were being attacked by an address that you thought came from hack, then you could email this guy and tell him, hey, I think one of your machines is blah blah blah. So that's a useful thing to know if you need to go find information about any particular domain and who you should contact for any issues related to that domain. So let's see how many more slides. Not many more slides. So that's some useful tools. Yeah, so that was a quick overview. Summary, you can use UDP or TCP, but usually it's UDP, port 53. Queries can be recursive or iterative. Getting your domain is fairly easy. And one more I didn't have on here, NS lookup and dig are some tools you can use to interrogate name servers. And you can look up information about who owns a domain in the Whois. So if you have any questions, put them on the discussion board or bring them to class. We will be configuring our own DNS server, so hopefully you will have a good idea what the different record types are that you're creating, and how to query for them to prove that your DNS server is working.